Now we are going to see the next topic, that is the non-conservative forces. So what are the non-conservative forces? So the again 2 points which will tell us how non-conservative force are different from the conservative force. So conservative force, as you know, they are the path independent, but they are the initial and final state dependent processes. But implicitly we can say the non-conservative forces are the forces which depend on the path. So they are path dependent forces, they depend on the path taken. So if you will change the path from going from first position to the final position, if you change the path, your work done by the non-conservative force is going to change, and it is independent of the initial and final positions. Okay, so it is the one which is path dependent. So if they are the positions, position 1 and final positions. So if it is a conservative force, if you go by any path between these two forces, and if it is a conservative force, the work is not going to change. But when the force is a non-conservative force, and if the point remains the same as in the case of conservative force, and you change the path, the work done by the conservative force in each and every path or each and every process is going to be different, because these are the forces which depend upon the path. So I'll write one of the points. So the non-conservative forces produce work which are dependent upon the path. Okay, so suppose this is the initial point, this is the initial point, and this is the final point. Okay, now suppose I go in a straight line. So this is a first case. Okay, now I go in, suppose, this path, this is a second position, and now suppose I go by this path, this is a third case. So here work done in first process is not equals to work done in second process, and it is not equals to work done in third process. But if it would have been a conservative force, the work done in each and every process, that is 1, 2 and 3, would have been same. But as it is a non-conservative force, the work done in first is not equals to second, and it is not equals to third. Work done from going from initial point to final point changes with the path taken. This is the non-conservative force. Now we will see what is the work done by a non-conservative force in a return process or return journey. So what is a return journey? I have told you return journey is one in which the initial and final points are the same. So suppose this is the initial point, okay? And now the body goes and again comes to this position. So this is also a final position. I have told you the non-conservative force is exactly opposite of a conservative force. Conservative force is the one in which in return process the work is 0, or it is the process in which depends upon the initial and final states. But here it does not depends upon the initial and final states. Okay, it depends upon the path taken. So when it goes from initial position to final position, the work done will not be 0, but work done will have some value, and this value will increase with increase in the path taken from going from position 1 to the final position. Okay, so the work done here by all the forces or the non-conservative force is not equals to 0. There will be some suitable considerable amount. So this is the non-conservative force in case of the return journey. Okay, so what are the examples of a non-conservative force? The most important example for non-conservative force is friction force. So tell me, if you go from your home and again come to your home again, is friction produced will be 0? No. So this is what you have to know from a return journey, that even though if you perform a return journey in case of a non-conservative force, your work done by the body is not going to remain 0. So what are its examples? The examples are frictional force, so any resistive force, resistance will increase with the increase in the path taken. So these are the examples of the non-conservative force. Okay, so if I just now we'll study and now we'll find out the difference between the non-conservative and conservative forces. So the conservative force and a non-conservative force. So in non-conservative force, first point, in non-conservative force the first point is depends upon initial and final position, but in this case it does not depends upon the initial and final position. So I'll write does not depend upon initial and final position. Okay, next point is, I have told you, next point is it does not depend upon the path taken. But in this case it depends path taken. Third point is return journey. So in the case of return journey, work done here is 0 because you know initial and final points are same. But in this case, in the case of return journey, the work done is not equals to 0 because it depends upon the path taken. So work done in this case is not 0, whereas in this case it is 0. Next is, I'll give you examples. Example is a gravitational force. And in this case the example is frictional force. Okay, so this was a summary of conservative force and the non-conservative force and difference between them. Hope this table makes you summarize all the points in one go. Okay. Now going on to the second point, the next point is potential energy. We have already seen kinetic energy. Now we are going to see potential energy. So what is a potential energy? So what was the definition of kinetic energy? Kinetic energy is the internal capacity of the body to work by the virtue of its motion. Okay, so it was dependent upon the motion. If the body is at rest, the kinetic energy is 0. If the body is moving, the body will have some kinetic energy. So if the body is in motion, there will be kinetic energy. But in the case of potential energy, the definition changes. What is the definition of potential energy? Potential energy is defined as the internal capacity of the body to work by the virtue of its position. So this position is now a very important term. So I'll write it is the internal capacity of body to do work by the virtue of its position. So the position is the most important point. So if the body has different positions, the potential energy it will possess will be different. The next most important point which I want to tell you is potential energy is a relative quantity. Okay, but kinetic energy isn't. So potential energy is a relative quantity. So if I ask you what is a potential, so what is, suppose I give you a situation and I ask you what is the potential energy of any particular body or any particular object. So the question is invalid Because the potential energy is a relative quantity. The question is wrong because question is incomplete. I have to ask what is the potential energy of a body with or object with respect to some surface or with respect to ground. So this with respect to is a very important term because potential energy in itself is a relative quantity. If I don't tell a potential energy or if I don't measure a potential energy with respect to some frame or with respect to ground or with respect to any surface or with respect to any body, it has to be with respect to some other thing. Otherwise the potential energy is invalid. Okay, so whenever you are asked potential energy, it has to be with respect to some other thing because the potential energy is a relative quantity. Now suppose a particular body will have a different potential energies with respect to different objects. The potential energy of that object with respect to me will be something, and that potential energy of that object with respect to any other person will be different. Hence potential energy is a relative quantity and it always has to be with respect to some any other object or any other point. So this is the importance of this point, that potential energy is a relative quantity. Okay, next is potential energy is only applicable in conservative force field. So this is a very important point. Potential energy can't be defined in a non-conservative field. It always can be defined only in a conservative force field, which we will know later on. So these are the must know points about the potential energy. Now we will go to the numerical aspect or some expressions about potential energy which will help us to solve the numericals. So I know potential energy is given by U. Okay, so this U is the potential energy. So I told you force which always has to be conservative in case when you are talking about potential energy, because I told you potential energy is defined only in the conservative force field. So this force is a conservative force. Okay, and this conservative force is equals to rate of change of potential energy. Okay, so it can also be defined as du by dt, but it's a very important point that there is a minus sign here. Okay, so I can say the conservative force is the rate of decline of potential energy. Okay, are you understanding it? So what does this expression say? The conservative force in which there is a particle is equals to rate of decline of potential energy. Why decline? Because there is a negative sign. Okay, so this is the reason why I said that it is a decline. So conservative force is equals to rate of decline of potential energy. So what is this minus du by dt? So it can be expressed as minus dou u x I cap upon dou t minus dou y j cap upon dou t minus dou z k cap upon dou t. So this dou u by dou t, dou y, so this has to be u. So what is this dou u x by dou t? This is the partial derivative. Here it was du by dt. This was a complete derivative, but this is a partial derivative and it has to be solved somewhat different from this complete or full derivatives. So you have to, up till now you have to understand one simple thing, that this is a partial derivative which is given by dou. So this is dou u by dou x, so this is dou u x by dou t, it is dou u y by dou t, and this is dou u z by dou t. So this is the most important thing which you have to keep in mind while solving the problems on the potential energy. Okay. So now we are going to see the numerical aspect, okay, of potential energy. So potential energy is given by U. Okay, so I am going to write an expression F conservative. What is F conservative? I have told you potential energy is defined only in the case of a conservative force field. So the force given here is a conservative force, and that will be equals to negative gradient of U. Okay, so this is given by a special symbol, that is minus dou U by dou x I cap minus dou U by dou y j cap minus dou U by dou y z k cap. So what is this dou? We have previously seen du by dx or du by dy or du by dz. They were the complete derivatives or the full derivatives. But here you can see dou u by dou x. This dou is a partial derivative, and you will know how to solve the problems when there is a partial derivative further. So for now you can understand that the conservative force is minus dou u by dou x I cap minus dou u by dou y j cap minus dou u by dou y dou z k cap. Okay, so this is the most important expression which you have to remember. Now we are going to see the next thing. We are going to see a graph which is very important with respect to examination point of view. So I'll draw a graph. So it has been observed that this is the R. What is R? The distance between any two points or a distance of an object with respect to any other point. Okay, so this is R, or the distance of separation. If you go up and you go down, so here U is negative and here U is positive. Here it is a repulsive field and here it is an attractive field. Okay, so this is the graph which you have to keep in mind, okay, because this graph is not going to change. It will be same and you will be asked questions depending on this graph. So what conclusions can we draw upon this graph? Okay, so first is conclusion number 1. So the first conclusion is that when there is a repulsive field, your U will be positive. Okay, so when there is a repulsive field, your U or potential energy is going to be positive. Okay, now here you can see when there is an attractive field, the potential energy will be negative. You can see the graph of repulsive field lies above the x-axis, that is, it lies in a positive y-axis, whereas the attractive field, the curve for attractive field lies below the x-axis. That means it is a negative y direction. So I can write a attractive field has U which is negative. So whenever you get a negative U, that is negative potential energy, you are going to say that the field is attractive. But when you are going to get potential energy positive, we are going to say the field is repulsive. So this is one conclusion which you can draw from this graph. Okay, so what is the next conclusion? Conclusion So the second conclusion. So what is the second conclusion? Now tell me, as you are increasing the distance between the two bodies, means you are increasing the R, and if you are increasing the R, you are going along the positive x-axis. So as you are going along the positive x-axis, you can see this graph is increasing, means the value of U is increasing. Means I can say if you increase R, okay, if R is increasing and if you see that U is also increasing. if u is also increasing, then I can say it is a graph of a attractive field. Yes? Again I will say, if you are increasing the r, that is distance of separation, and if you see u is increasing with that r, okay, so I am going in this direction of positive y-axis, and in this graph I am seeing that the value of u is increasing. Here it will be -5, here it will be -4, here it will be -3, and go on, and it will become increasing, increasing, and increasing. Okay, so in such cases, if you see r increasing and it with simultaneously you see u is also increasing, then you can deduce one thing, that the field is attractive. Next conclusion, if again you see if r is increasing but you see u is decreasing, so which of these both graphs you can see u increasing? So it is this graph in which you can say with increasing r the u is decreasing. Suppose here it is +5, here it is going to be +4, +3, +2, and so on, it will go on decreasing. So with increasing r, if you see a decreasing potential energy, then it will be this graph, and I know this graph is a repulsive field because it lies above positive y-axis. So it is a repulsive field. So these are two conclusions which are very, very important with respect to this graph. So this is the one graph which you have to understand and keep it in your mind, so that you can solve most of the questions which come upon this graph. Okay. तो नज़्म